The fluorescent lights in warehouse building 47 cast harsh shadows across endless rows of metal shelving, each section meticulously labeled with alphanumeric codes that most people couldn't decipher without a manual. But Sarah Chen didn't need a manual. She knew every bolt, every gasket, every component specification by heart. At 5:30 in the morning, when the rest of Fairfield Air Base was still wrapped in pre-dawn darkness, Sarah was already 3 hours into her shift, moving between the towering storage units with the quiet precision of someone who understood that every part she cataloged could mean the difference between mission success and catastrophe. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed, because tomorrow, I've saved something extra special for you. The warehouse smelled of machine oil and cardboard, with the faint metallic tang that came from housing thousands of aircraft components. Sarah's clipboard never left her side, filled with requisition forms written in her neat, careful handwriting. She wore standard-issue work clothes, steel-toed boots that had seen better days, and safety glasses that perpetually fogged up in the humid storage areas. Her black hair was pulled back in a practical ponytail, secured with a rubber band she'd found on the warehouse floor 6 months ago. Nothing about her appearance suggested she held 3 engineering degrees or that she could identify engine failure patterns by sound alone. The morning inventory report stretched across Sarah's desk like a paper landscape of technical specifications and delivery schedules. Each form represented hours of cross-referencing part numbers with maintenance records, matching serial numbers to aircraft assignments, and ensuring that every component met the exacting standards required for military aviation. Sarah approached each requisition with the same methodical attention, whether it was a request for standard hydraulic fluid or a rare turbine blade assembly worth more than most people's houses. Master Sergeant Tom Rodriguez entered the warehouse just as Sarah finished checking the shipment of fuel injection components. He carried himself with the swagger of someone who'd spent 22 years in the Air Force and believed his experience gave him authority over anyone wearing civilian clothes. His uniform was pressed to perfection, with ribbons and badges that caught the warehouse lighting as he walked. Sarah had worked under Rodriguez for 18 months, and in all that time, he had never asked for her opinion on anything more complex than lunch preferences. Rodriguez approached her workstation with a clipboard of his own, this one bearing the official seal of the Base Maintenance Division. His expression carried the particular brand of impatience that came from dealing with what he considered administrative busy work. Sarah looked up from her computer screen, where she had been tracking the delivery status of engine components for the upcoming training exercises. Her workspace was organized with military precision, despite never having served herself. Pens, arranged by color, forms stacked in perfect right angles, reference manuals bookmarked with color-coded tabs. The requisition Rodriguez placed on her desk was different from the usual requests. Sarah recognized the aircraft identification numbers immediately. Alpha Squadron was scheduled for advanced combat maneuvers later that week, flying missions that would push both pilots and aircraft to their operational limits. The parts list included several high-stress components, turbine blades, combustion chamber assemblies, and fuel system regulators. Sarah scanned the specifications, noting discrepancies between the requested part numbers and the aircraft models listed. Rodriguez tapped the form with his index finger, leaving a small smudge on the paper. He spoke without looking at Sarah directly, his eyes focused on something beyond the warehouse shelves. The tone of his voice suggested this was a routine transaction, nothing that required discussion or analysis. Sarah examined the requisition more carefully, cross-referencing the part numbers with her computer database. The discrepancies weren't just minor clerical errors. Several of the requested components were rated for different engine configurations, with tolerance specifications that wouldn't match the aircraft in question. When Sarah pointed out the inconsistencies, Rodriguez's Expression shifted to the particular kind of annoyance reserved for subordinates who overcomplicated simple tasks. He explained that the requisition had been prepared by the maintenance chief himself, a man with more aviation experience than Sarah had years of life. The implication was clear. Her job was to fulfill orders, not to question them. Sarah tried to elaborate on the technical specifications, explaining how the wrong components could lead to performance degradation or worse. But Rodriguez had already moved on to other matters. The morning progressed with its usual rhythm of deliveries, inventory updates, and requisition processing. Sarah handled each task with the same careful attention, but her mind kept returning to the Alpha Squadron parts list. During her lunch break, instead of joining the other civilian employees in the break room, she remained at her desk and pulled up the maintenance records for the aircraft in question. The files revealed a pattern that made her increasingly uncomfortable. 3 of the F-15 fighters in Alpha Squadron had undergone recent engine modifications, upgrading from standard configurations to enhanced performance specifications. The modifications were relatively new, implemented just 6 weeks earlier as part of a base-wide modernization program. Sarah found the engineering documentation for the upgrades, thick technical manuals filled with detailed schematics and component specifications. Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel. It means a lot to us. Now back to the story. The upgraded engines required specific parts with tighter tolerances and different metallurgical properties than their predecessors. Rodriguez's requisition called for the older specification components, the ones that had been standard before. The modifications. Sarah realized that installing these parts in the upgraded engines would create compatibility issues that might not manifest immediately, but could lead to progressive degradation under stress. The components would fit physically, the connections would seal properly, and initial performance tests would likely show normal parameters. But under the extreme conditions of combat training, with engines operating at maximum thrust and pilots pushing aircraft to their limits, the mismatched components could fail catastrophically. Sarah spent the remainder of her lunch break documenting her findings, creating a detailed analysis that compared the requisitioned parts to the actual requirements of the modified engines. She printed relevant pages from the technical manuals, highlighted the critical specifications, and prepared a comprehensive report that explained both the immediate and long-term risks of proceeding with the incorrect components. Her analysis was thorough, methodical, and irrefutable. When Rodriguez returned from his own lunch break, Sarah presented her findings with the respectful professionalism she had learned was necessary when challenging authority. She explained the engine modifications, detailed the specification mismatches, and outlined the potential consequences of installing incompatible components. Rodriguez listened with the expression of someone enduring an unnecessary lecture. When Sarah finished her presentation, he reminded her that requisitions came from qualified maintenance personnel who understood aircraft systems far better than warehouse staff. The afternoon brought a steady stream of routine requests that Sarah processed with mechanical efficiency while her thoughts remained focused on Alpha Squadron. She watched through the warehouse windows as aircraft moved across the distant flight line, their movements precise and purposeful. Each plane represented millions of dollars in advanced technology and, more importantly, the life of a pilot who trusted that every component had been selected and installed correctly. Sarah understood that trust in a way that transcended job descriptions and organizational hierarchies. As the day shift neared its end, Sarah made one final attempt to address the requisition issue. She approached Rodriguez's office, a small space carved out of the warehouse floor with glass walls that provided visibility across the entire facility. Rodriguez was completing paperwork, his attention divided between forms and a phone conversation about scheduling conflicts. Sarah waited until he finished the call before presenting a simplified version of her earlier analysis. focusing on the most critical compatibility issues. Rodriguez's response was swift and definitive. The requisition had been approved by people with more authority and experience than Sarah possessed. Her job was to locate the requested parts and prepare them for delivery, not to second-guess decisions made by qualified personnel. He suggested that Sarah focus on her assigned responsibilities and leave aircraft maintenance to the professionals. The conversation ended with Rodriguez returning to his paperwork, effectively dismissing both Sarah and her concerns. The warehouse grew quiet as the day shift departed, leaving Sarah alone with the endless rows of components and the weight of knowledge no one wanted to hear. She completed the Alpha Squadron requisition, locating each part according to the specifications provided. The components were in perfect condition, properly stored and documented, ready for installation. Everything was correct, except for the fundamental fact that they were wrong for the aircraft that would carry them into the sky. Sarah's evening routine included a final walk through the warehouse, checking that all systems were secure and all deliveries were properly staged for morning pickup. The Alpha Squadron components sat in a marked container near the shipping dock, each part wrapped in protective material and accompanied by documentation certifying its specifications and condition. Sarah stood beside the container for several minutes, weighing her professional obligations against her technical knowledge and ethical concerns. The base had protocols for reporting safety concerns, channels that allowed personnel to escalate issues beyond their immediate supervisors. Sarah had researched these procedures during her lunch break, identifying the appropriate offices and officials who could review her findings. But she also understood the realities of military hierarchy and the career consequences faced by civilian employees who challenged established authority. Her position as a supply clerk afforded her certain protections but also limited her credibility when disputing technical decisions made by career military personnel. That evening, Sarah remained in the warehouse long after her shift officially ended, using her computer access to compile a more comprehensive analysis of the Alpha Squadron situation. She gathered maintenance histories, modification records, component specifications, and failure analysis reports from similar aircraft configurations. Her research painted a clear picture of the risks involved in using incompatible components, supported by documented cases where similar mismatches had led to engine failures and mission aborts. The documentation process was meticulous and time-consuming, requiring Sarah to translate technical jargon into language that non-specialists could understand, while maintaining the precision necessary for engineering evaluation. She created charts comparing specifications, highlighted critical differences, and calculated performance margins under various operational scenarios. The resulting report was comprehensive enough to support formal safety review and detailed enough to guide corrective action. As midnight approached, Sarah saved her work to multiple locations and prepared copies for distribution through proper channels. She had done everything possible within the constraints of her position and authority. The next morning would bring new challenges and decisions, but Sarah felt confident that she had fulfilled her professional obligations by documenting and reporting the safety concerns she had identified. The warehouse security system activated automatically as Sarah gathered her personal belongings and prepared to leave. The building settled into nighttime stillness, its rows of components waiting patiently for tomorrow's requisitions and deliveries. Sarah locked her workstation and walked toward the exit, her footsteps echoing in the vast space. She paused at the door for one final look at the Alpha Squadron container, knowing that morning would bring either vindication of her concerns or confirmation that her technical analysis would be dismissed by those with greater authority and less specific knowledge. The drive home took Sarah through the residential section of the base, past houses where pilots and maintenance personnel slept peacefully, trusting that tomorrow's missions would proceed safely and successfully. Sarah carried that trust like a weight, understanding that her technical knowledge came with ethical responsibilities that transcended job descriptions, and organizational boundaries. The decisions made in the next few days would determine whether her analysis proved correct and whether anyone would listen when a supply clerk tried to prevent a potential catastrophe. Sarah's apartment was a modest space reflecting the practical sensibilities of someone who valued function over appearance. Her bookshelves contained technical manuals and engineering references, accumulated during years of study and professional development. Her desk held additional copies of the analysis she had prepared, along with contact information for various safety offices and review boards. Sarah spent the evening reviewing her documentation one final time, ensuring that her technical arguments were sound and her recommendations were clear. The next morning arrived with the crisp clarity that preceded complex decisions and challenging conversations. Sarah returned to Warehouse Building 47, knowing that the Alpha Squadron components were scheduled for pickup and delivery to the maintenance hangars. Her analysis and recommendations had been prepared and documented, but the question remained whether anyone with sufficient authority would review her findings before the installation process began. Rodriguez arrived at his usual time, carrying his morning coffee and the particular confidence of someone who rarely questioned established procedures. Sarah watched him settle into his routine, knowing that she would soon need to make one final attempt to ensure her safety concerns received appropriate consideration. The warehouse hummed with activity as other staff members began their shifts, unaware of the technical drama unfolding in their midst. The morning inventory reports contained routine requests for standard components, creating a contrast with the specialized requirements of the Alpha Squadron situation. Sarah processed each request with her usual attention to detail while monitoring the status of the more critical delivery. The maintenance team was scheduled to begin work later that morning, following procedures that assumed all components had been properly specified and selected. As the morning progressed, Sarah realized that her window for intervention was closing rapidly. The Alpha Squadron components would soon leave the warehouse and enter the installation process, where detecting compatibility issues would become more difficult and correcting them would require significant time and resources. Sarah made her final decision based on the weight of her technical knowledge and the ethical obligations that came with expertise in critical systems. The conversation with Rodriguez was brief and decisive. Sarah presented her analysis one final time, emphasizing the most critical safety concerns and offering specific recommendations for addressing the compatibility issues. Rodriguez listened with the patience of someone fulfilling a bureaucratic requirement before proceeding with predetermined actions. His response remained unchanged. Qualified personnel had made appropriate decisions based on their expertise and authority. Sarah understood that her formal obligations had been fulfilled, and that further action would require her to step beyond the traditional boundaries of her position. The Alpha Squadron components sat ready for delivery, properly documented and certified according to the specifications provided. Everything was proceeding according to established procedures, despite the technical knowledge that suggested those procedures were flawed in this specific instance. The morning delivery truck arrived precisely on schedule, ready to transport the Alpha Squadron components to their destination in the maintenance hangars. Sarah watched as warehouse staff loaded the container, each part still wrapped in protective material and accompanied by documentation certifying its condition and specifications. The delivery process was efficient and professional, executed by personnel who trusted that every component had been properly selected and verified. As the truck departed with its critical cargo, Sarah remained at her workstation, processing routine requisitions while knowing that somewhere across the base, maintenance personnel were beginning work that could determine the safety of upcoming missions. Her technical analysis remained filed in various locations, available for review by anyone with sufficient authority and interest. Sarah had done everything possible within the constraints of her position, but the question remained whether expertise without authority could prevent potential catastrophe when established procedures proved insufficient. The maintenance hangar buzzed with activity as dawn broke across Fairfield Air Base, casting long shadows through the massive open doors. Chief Petty Officer Michael Brennan stood beneath the raised nose of an F-15 Eagle, his weathered hands tracing the intricate network of fuel lines that fed the aircraft's twin engines. Brennan had spent 15 years working on fighter jets, earning his reputation through countless successful repairs and modifications. His crew respected him for his ability to diagnose problems that stumped younger technicians and his superiors, trusted his judgment when it came to complex maintenance decisions. The Alpha Squadron aircraft represented the culmination of months of preparation for the upcoming Red Flag exercises, where pilots and ground crews would demonstrate their readiness for real-world combat scenarios. Each F-15 had undergone extensive modifications as part of the base's modernization program, receiving upgraded engines capable of sustained high-performance operation. The modifications were cutting-edge technology designed to push the aircraft beyond their original specifications while maintaining the reliability that had made the Eagle platform legendary. Hayes commanded the base's flying operations and took personal responsibility for ensuring that every aircraft met the highest standards of safety and performance. Her background included 23 years of military aviation with experience in both combat operations and training command. Hayes trusted her maintenance personnel but maintained direct oversight of critical operations that could affect pilot safety. Brennan briefed Hayes on the morning's work, describing the component installations and the results of initial testing. Hayes reviewed the maintenance documentation, noting the minor variations that had been observed in the replacement parts. The variations appeared to be within normal tolerances, and Brennan's assessment was that the aircraft were ready to proceed with scheduled testing procedures. Hayes approved the next phase of preparation, authorizing the comprehensive system checks that would verify aircraft readiness. The system testing process began with ground-based evaluations that exercised each aircraft component under simulated operational conditions. The fuel systems were tested at various flow rates and pressures, confirming that the injection assemblies could deliver appropriate fuel quantities under different engine operating modes. The electrical systems underwent diagnostic testing that verified signal transmission and sensor accuracy across the full range of operational parameters. The hydraulic systems were cycled through their complete range of motion, confirming that control surfaces responded properly to pilot inputs. Park conducted the fuel system testing on Alpha 7, following procedures that had been refined through years of experience with F-15 maintenance. The fuel injection assemblies responded normally to throttle inputs, delivering appropriate fuel quantities at each test point. The fuel flow patterns appeared smooth and consistent, with no evidence of irregularities that would indicate component problems. Park completed her testing and signed off on the fuel system certification, indicating that the aircraft was ready for flight operations. Martinez performed electrical system diagnostics on the same aircraft, using computer-controlled test equipment that could detect signal anomalies measured in milliseconds. The electrical components responded properly to test signals, maintaining accurate sensor readings and reliable communication between system elements. The test results showed normal operation across all monitored parameters, confirming that the electrical modifications had been completed successfully. Martinez documented his findings and approved the aircraft for continued preparation. Walsh completed hydraulic system testing by cycling the control surfaces through their full range of motion while monitoring pressure and flow characteristics. The hydraulic regulators maintained stable pressure under varying load conditions, ensuring that control surfaces would respond predictably to pilot inputs. The system performance met all specified requirements, with response times and pressure levels that fell within established tolerances. Walsh certified the hydraulic systems, as ready for flight operations. The testing process was repeated for each aircraft in Alpha Squadron, with Brennan's team conducting comprehensive evaluations that verified the performance of every installed component. The results were consistently positive, showing that all systems operated within specified parameters and that the aircraft were ready for the next phase of preparation. The minor variations observed during installation appeared to have no significant impact on overall system performance. Brennan compiled the test results into a comprehensive report that documented the successful completion of the maintenance work. The report included detailed measurements from each test procedure, along with his professional assessment that all aircraft were ready for flight operations. The documentation would be reviewed by multiple levels of authority before the aircraft were cleared for pilot operations, providing additional verification that safety standards had been maintained. The afternoon also brought the arrival of Captain James Mitchell, the lead pilot for Alpha Squadron and the officer responsible for final acceptance of the modified aircraft. Mitchell had over 2,000 hours of F-15 flight time and was known throughout the base for his meticulous attention to aircraft performance and safety. His pre-flight evaluations were legendary for their thoroughness, often detecting minor problems that had been missed by ground crews and maintenance personnel. Mitchell began his evaluation with Alpha 7, conducting a detailed walk-around inspection that examined every external component and connection. He checked control surface movement, landing gear operation, and external system indicators that could reveal problems with internal components. Mitchell's inspection revealed no obvious defects or anomalies, confirming that the aircraft appeared ready for flight operations from a pilot's perspective. The cockpit evaluation involved checking the operation of every switch, indicator, and control system that would be used during flight operations. Mitchell tested the fuel system controls, confirming that throttle inputs produced appropriate responses from the fuel injection assemblies. The electrical system indicators showed normal readings across all monitored parameters, and the hydraulic pressure gauges confirmed that control systems were operating within acceptable ranges. Mitchell found no discrepancies that would prevent the aircraft from being cleared for flight. Mitchell repeated his evaluation process for each aircraft in Alpha Squadron, conducting the same thorough inspection and testing procedures. His findings were consistent across all aircraft, showing that the maintenance work had been completed to appropriate standards and that the planes were ready for operational use. Mitchell's approval was the final step in the certification process, authorizing the aircraft for participation in the upcoming training exercises. The Alpha Squadron aircraft were moved to the flight line late in the afternoon, positioned for easy access during the next morning's pre-flight preparations. Each plane carried documentation certifying that it had passed all required inspections and was approved for flight operations. Brennan's team worked with practiced efficiency, following procedures that had been refined through decades of military aviation maintenance. Sergeant Lisa Park handled the fuel system components with the careful attention of someone who understood that a single misinstalled part could ground an aircraft for weeks. Corporal David Martinez focused on the electrical connections, ensuring that every wire was properly seated and every sensor was correctly calibrated. Staff Sergeant Jennifer Walsh managed the hydraulic systems, checking pressures and flow rates, with instruments that could detect variations measured in fractions of percentage points. The morning's work began with the installation of components that had arrived from the supply warehouse the previous evening. Each part came with documentation certifying its specifications and compatibility, processed through the same supply chain that had supported base operations for years without significant problems. Brennan trusted the system, knowing that supply personnel were trained to match components with aircraft requirements and that multiple levels of review prevented critical errors from reaching the flight line. Park opened the first container and began removing fuel injection assemblies. each component wrapped in protective material and tagged with identification numbers that corresponded to the maintenance work orders. The parts appeared to be in perfect condition, with machined surfaces that gleamed under the hanger lights and tolerance markings that indicated precision manufacturing. Park had installed hundreds of similar components throughout her career, and these showed no obvious signs of defects or damage that would prevent their use. Martinez unwrapped the electrical components, finding connector assemblies and sensor units that matched the general configuration required for the F-15 systems. The parts fit properly into their designated locations, with mounting points that aligned correctly and connection interfaces that engaged smoothly. The electrical continuity tests showed normal readings, confirming that current flow and signal transmission were within acceptable parameters. Nothing in the initial installation process suggested any problems with the components or their integration into the aircraft systems. Walsh examined the hydraulic regulators, components that controlled fluid pressure and flow throughout the pavilion. Aircraft's control systems. The regulators appeared identical to units she had installed in other aircraft, with the same mounting configurations and connection specifications. The pressure testing equipment confirmed that each unit operated within its designated parameters, maintaining stable output under varying input conditions. The hydraulic system integration proceeded smoothly, with no anomalies detected during the initial testing phases. Brennan supervised the installation process while reviewing the technical documentation that accompanied each component. The paperwork indicated that all parts met military specifications and had been properly certified for use in F-15 aircraft. The supply warehouse had provided components that matched the requested part numbers, following procedures that had been standard practice for years. Brennan saw no reason to question the compatibility of parts that had been specifically requested by qualified maintenance personnel. The first aircraft in the modification sequence was Alpha 7, a fighter that had accumulated over 3,000 flight hours since its original commissioning. The plane had undergone the engine upgrade 6 weeks earlier, receiving enhanced turbine assemblies and modified fuel systems designed to support increased performance demands. The current maintenance work involved replacing several components that had reached their scheduled service intervals, routine procedures that were performed regularly throughout the fleet. As the morning progressed, Brennan's team completed the installation of components in Alpha 7 and began work on Alpha 12, another aircraft scheduled for the upcoming exercises. The second installation proceeded with the same efficiency and attention to detail, with each technician following established procedures and conducting required inspections. The parts fit properly, the connections sealed correctly, and the initial system tests showed normal operation across all monitored parameters. Park noticed minor variations in some of the component specifications, differences that appeared to be within normal manufacturing tolerances. The fuel injection assemblies had slightly different flow rates than the units they replaced, but the variations fell within the acceptable range specified in the technical manuals. Park documented the differences in her maintenance logs following standard practice for component replacements that showed any deviation from nominal specifications. Martinez encountered similar variations in the electrical components, finding that some connector assemblies had different internal resistance values than their predecessors. The differences were small, measured in fractions of ohms, and remained well within the acceptable range for the system's electrical requirements. Martinez noted the variations in his records while continuing with the installation process, confident that the components would perform adequately in their operational environment. Walsh observed that the hydraulic regulators operated at pressures that were slightly lower than the units they replaced, but still within the specified range for normal operation. The pressure differentials were consistent across multiple units, suggesting that the variations represented normal manufacturing differences rather than defects or quality control problems. Walsh completed her installation work and documented the pressure readings in the appropriate maintenance records. The installation work continued throughout the morning, with Brennan's team completing modifications to 3 additional aircraft in Alpha Squadron. Each installation followed the same pattern, with components that fit properly and operated within specified parameters, but showed minor variations from their predecessors. The variations were individually insignificant, falling within tolerances that had been established to accommodate normal manufacturing differences and operational wear. Brennan reviewed the completed work with satisfaction, knowing that his team had maintained their reputation for thorough and professional maintenance. The aircraft were ready for the next phase of preparation, which would involve comprehensive system testing and performance verification. The F-15s would undergo extensive ground testing before being cleared for flight operations, providing multiple opportunities to detect any problems that might have been missed during the installation process. The afternoon brought Colonel Patricia Hayes to the maintenance hangar, making her routine inspection of the Alpha Squadron aircraft. The aircraft appeared ready to demonstrate the capabilities that had made the F-15 platform one of the most successful fighter designs in aviation history. As evening approached, Brennan's team completed their final inspections and secured the maintenance hangar for the night. The successful completion of the Alpha Squadron modifications represented weeks of careful planning and execution, demonstrating the professionalism and expertise that had made Fairfield Air Base a model facility for aircraft maintenance. The next morning would bring the ultimate test of their work, as pilots would take the modified aircraft into the sky for the first time since the component installations. The maintenance documentation was filed in the appropriate offices, creating a permanent record of the work that had been performed. The reports included detailed specifications for every installed component, along with test results that confirmed proper operation under simulated conditions. The paperwork trail provided accountability and traceability that would support future maintenance decisions and component replacement schedules. Brennan remained in the hangar after his team departed, conducting a final review of the day's work and ensuring that all tools and equipment had been properly secured. His experience told him that the aircraft were ready for flight operations, with all systems functioning within acceptable parameters and all required inspections completed successfully. The minor variations observed in some components were well within normal tolerances and should have no impact on aircraft performance or safety. The evening brought a sense of satisfaction for work completed professionally and efficiently. Alpha Squadron was ready for the challenges that lay ahead, equipped with aircraft that represented the best in military aviation technology and maintenance practices. The modifications had been completed according to established procedures, with components that met all specified requirements and systems that operated within acceptable parameters. Outside the hangar, the flight line stretched into the distance, dotted with aircraft that represented millions of dollars in advanced technology and thousands of hours of maintenance work. Each plane was a testament to the skill and dedication of the personnel who kept them flying, from the engineers who designed them to the technicians who maintained them. The Alpha Squadron aircraft were ready to join this proud tradition, carrying pilots into training exercises that would prepare them for real-world operations. As night settled over Fairfield Air Base, the Alpha Squadron aircraft sat silently on the flight line, their systems powered down but ready for activation at first light. The next morning would bring the ultimate validation of the maintenance work, as pilots would trust their lives to the aircraft and components that had been installed and tested according to established procedures. The stage was set for the next phase of operations, where theoretical preparation would meet practical application in the unforgiving environment of high-performance military aviation. The piercing wail of the emergency alarm cut through the peaceful morning air at Fairfield Air Base, sending personnel scrambling from their coffee breaks and routine duties. The sound echoed across the flight line where Alpha Squadron's F-15 Eagles had been conducting their first high-performance training mission since the recent component installations. What had begun as a routine exercise in advanced combat maneuvers had suddenly transformed into every pilot's worst nightmare and every ground crew's most feared scenario. Captain James Mitchell's voice crackled through the control tower radio with the kind of controlled urgency that veteran pilots developed when facing life-threatening emergencies. His aircraft Alpha 7 had experienced what he initially described as minor engine irregularities during a high G turn at 35,000 feet. The irregularities had rapidly escalated into severe vibrations, power fluctuations, and warning. Indicators that painted his cockpit display in ominous shades of red and amber. Mitchell was requesting immediate clearance for emergency landing procedures while his wingman, Captain Rebecca Torres in Alpha 12, reported similar but less severe anomalies developing in her own aircraft. The control tower erupted into controlled chaos as air traffic controllers began clearing airspace and alerting emergency response teams. Fire trucks and ambulances moved into position along the runway, while medical personnel prepared for potential casualties. The base commander, Brigadier General William Thompson, arrived at the tower within minutes of the initial emergency call, his expression reflecting the gravity of a situation that could result in the loss of both aircraft and pilots. Master Sergeant Rodriguez stood in the communication center adjacent to the main tower, monitoring radio frequencies that carried technical data from the troubled aircraft. His usual confidence had evaporated as he listened to engine performance. Readings that made no sense according to the maintenance records. The recently installed components should have been operating flawlessly, providing enhanced performance rather than creating the catastrophic problems that were now threatening two of his squadron's most experienced pilots. Sarah Chen received notification of the emergency through the base-wide alert system while she was conducting routine inventory procedures in Warehouse Building 47. The message was brief and clinical, mentioning aircraft emergencies and requesting all personnel to remain at their duty stations unless specifically summoned. Sarah's blood ran cold as she realized that Alpha Squadron was experiencing exactly the kind of problems she had tried to warn about. Problems that stemmed from the incompatible components that had been installed despite her detailed technical analysis. The gravity of the situation became clear as additional details filtered through official channels. Mitchell's aircraft was losing power systematically, with fuel flow irregularities that suggested problems with the recently installed injection assemblies. The fuel system was delivering inconsistent quantities to the engine, creating power variations that made controlled flight increasingly difficult. The engine temperature readings were climbing beyond normal parameters, indicating that the mismatched components were creating thermal stress that could lead to catastrophic failure. Torres reported that her aircraft was experiencing similar but less severe symptoms, with power fluctuations that occurred primarily during high-stress maneuvers. Her fuel system was showing intermittent irregularities that created momentary power drops, forcing her to reduce throttle settings and avoid aggressive maneuvering. The electrical systems were also displaying anomalous readings, with sensor outputs that fluctuated randomly and created uncertainty about actual engine conditions. The emergency response intensified as both aircraft attempted to return to base. Under increasingly difficult conditions, Mitchell's situation was deteriorating rapidly, with engine power continuing to decline and temperature readings approaching critical levels. The cockpit warning systems were providing conflicting information, making it difficult for him to assess the true extent of his aircraft's problems or to determine the best course of action for maintaining controlled flight. Chief Petty Officer Brennan arrived at the maintenance hangar as soon as he received notification of the emergency, immediately beginning a review of the recent work performed on both affected aircraft. His team gathered around computer terminals displaying maintenance records and component specifications. searching for any anomalies that might explain the sudden emergence of critical problems. The maintenance logs showed that all procedures had been followed correctly and that all installed components had passed required inspections. The technical data streaming from the troubled aircraft painted a picture that defied conventional understanding of engine operation and component behavior. The fuel injection assemblies were operating inconsistently, with flow patterns that created uneven combustion and power variations. The electrical sensors were providing readings that fluctuated randomly, making it impossible for pilots to maintain accurate awareness of engine conditions. The hydraulic regulators were showing pressure variations that affected control system responsiveness. Rodriguez found himself in the uncomfortable position of having to explain to senior officers why aircraft that had recently passed comprehensive inspections were now experiencing life-threatening emergencies. His initial response focused on the possibility of multiple component failures occurring simultaneously, an unlikely but theoretically possible scenario. The alternative explanation, that fundamental errors had been made in component selection or installation, was too disturbing to consider given the potential implications for other aircraft in the fleet. Sarah realized that her worst fears were being confirmed in real time, with consequences that extended far beyond administrative procedures or professional disagreements. The incompatible components she had identified were causing exactly the kind of progressive failures she had predicted, creating dangerous conditions that threatened the lives of pilots who had no knowledge of the underlying technical problems. Her analysis had been thorough and accurate, but it had been dismissed by personnel who lacked the specific expertise needed to understand the implications. The emergency became more critical as Mitchell reported that his aircraft's condition was continuing to deteriorate despite his attempts to manage the engine problems through throttle control and system adjustments. The power fluctuations were becoming more severe and more frequent, making it increasingly difficult to maintain stable flight. The temperature readings were approaching levels that could trigger automatic engine shutdown systems, which would leave him with no choice but to attempt ejection over unfamiliar terrain. Torres managed to stabilize her aircraft's condition somewhat by reducing power settings and avoiding high-stress maneuvers, but her situation remained precarious. The intermittent power fluctuations continued to occur unpredictably, creating the constant threat that her engine could suddenly lose power during critical phases of flight, such as landing approach. Her fuel system readings remained erratic, making it difficult to accurately assess remaining fuel quantities or to predict how long her engine would continue operating. The control tower coordinated with emergency response teams to prepare for multiple scenarios, including successful emergency landings, forced ejections, and potential aircraft crashes. Medical personnel established triage areas near the runway while fire suppression teams positioned equipment to respond quickly to any fuel fires or explosions. The base's most experienced pilots were placed on standby to provide assistance and guidance to the pilots in distress. Brennan's review of maintenance records revealed the minor variations in component specifications that his team had documented during installation, variations that had seemed insignificant at the time, but now appeared potentially relevant to the current crisis. The fuel injection assemblies had shown slightly different flow rates than their predecessors, differences that were within acceptable tolerances, but might contribute to the irregular combustion patterns being experienced by the troubled aircraft. The electrical components had exhibited minor resistance variations that had been deemed acceptable during installation testing, but these variations could explain the erratic sensor readings that were preventing pilots from accurately assessing their aircraft's condition. The hydraulic regulators had operated at pressures slightly lower than nominal values, variations that could affect control system responsiveness during high-stress maneuvering. Rodriguez began to understand that the seemingly minor variations observed during installation might collectively create the systematic problems now threatening both aircraft. Individual component variations within acceptable tolerances could combine to produce overall system performance that fell outside acceptable parameters, particularly under the extreme conditions encountered during high-performance military aviation. Operations. Sarah made the decision to leave her assigned duty station and report to the Emergency Command Center with her technical analysis and documentation. She understood that violating orders to remain at her post could result in disciplinary action, but she also knew that her expertise might be the key to understanding and resolving the crisis. Her detailed analysis of component compatibility issues provided insights that might not be available to personnel focused on emergency response procedures. The command center was a scene of controlled intensity as senior officers coordinated response efforts and assessed options for resolving the emergency. General Thompson presided over briefings from air traffic control, emergency response teams, and maintenance personnel while making critical decisions about aircraft recovery procedures. The atmosphere was tense but professional, reflecting the military's ability to function effectively under extreme pressure. Mitchell's situation reached a critical point as his aircraft's engine began experiencing severe power fluctuations that made controlled flight extremely difficult. The fuel system problems had progressed to the point where the engine was receiving inconsistent fuel delivery, creating combustion irregularities that produced dangerous vibrations throughout the airframe. The cockpit warning systems were displaying multiple caution and warning indicators, suggesting that various aircraft systems were approaching or exceeding operational limits. The decision was made to attempt an emergency landing despite the uncertain condition of Mitchell's aircraft, with Torres providing close support and ready to assist with navigation and communication. If Mitchell's systems failed completely, the approach would be conducted at reduced speed to minimize stress on the compromised engine, with emergency response teams positioned to respond immediately to any problems during the landing sequence. Sarah arrived at the command center carrying her comprehensive analysis of the Alpha Squadron component compatibility issues, documentation that detailed the specific technical problems she had identified weeks earlier. Her appearance surprised personnel who expected to see only senior military officers during emergency operations, but her credentials as the supply clerk responsible for the affected components gave her unique insights into the developing crisis. The technical briefing Sarah provided transformed the understanding of the emergency from multiple random component failures to systematic compatibility problems stemming from incorrect part specifications. Her analysis explained why the engine problems were occurring, why they were progressing in predictable patterns, and why they would likely continue to worsen unless fundamental corrective action was taken. The documentation supported her conclusions with detailed engineering analysis and reference to manufacturer specifications. General Thompson reviewed Sarah's analysis while monitoring communications from the aircraft, attempting emergency approaches, recognizing that her technical insights might be crucial for preventing similar emergencies in other aircraft. The systematic nature of the problems suggested that additional aircraft might be experiencing early stages of the same component compatibility issues, creating the potential for multiple simultaneous emergencies that could overwhelm the bases. Emergency response capabilities. Rodriguez found himself confronting the reality that his dismissal of Sarah's earlier warnings had contributed directly to the current crisis, a realization that carried both professional and personal implications. The supply clerk he had considered unqualified to question maintenance decisions had possessed technical knowledge that could have prevented the emergency currently threatening two pilots' lives. His failure to review her analysis represented a breakdown in communication and decision-making that had serious consequences. Mitchell's emergency approach began with his aircraft showing signs of continued deterioration, engine power fluctuating unpredictably as he attempted to maintain controlled descent toward the runway. The fuel system irregularities were creating combustion problems that produced visible smoke from the exhaust, indicating that internal engine components were operating under extreme stress. Torres maintained close formation to provide immediate assistance if Mitchell's aircraft suffered. Complete power failure. The landing sequence proceeded with emergency response teams, tracking every aspect of the aircraft's approach, ready to respond instantly to any signs of complete engine failure or loss of control. Mitchell's skill as a pilot was evident in his ability to maintain stable flight despite the severe engine problems, adjusting continuously for power fluctuations while managing aircraft systems that were operating outside normal parameters. Brennan coordinated with the command center to provide technical support for the emergency landing attempts, using his maintenance expertise to interpret aircraft system readings and predict likely failure modes. His team prepared for immediate post-landing inspections that would assess the extent of engine damage and determine whether the affected aircraft could be repaired or would require complete engine replacement. Sarah's presence in the command center provided real-time technical consultation as the emergency progressed, allowing decision-makers to understand the underlying causes of the aircraft problems and to make informed choices about recovery procedures. Her analysis indicated that the engine problems were likely to continue worsening, but that catastrophic failure was not imminent if power settings were kept below critical thresholds. The first emergency landing was completed successfully despite continued engine irregularities, with Mitchell bringing his aircraft to a controlled stop on the runway, while fire suppression teams stood ready to respond to any fuel fires or other complications. Post-landing inspection revealed extensive evidence of internal engine stress, with components showing signs of thermal damage and mechanical wear that confirmed Sarah's predictions about progressive failure patterns. Torres completed her emergency approach with fewer complications, her aircraft's less severe symptoms allowing for a more normal landing sequence. However, post-landing analysis revealed that her engine was experiencing the early stages of the same compatibility problems, confirming that the component issues affected multiple aircraft and would likely continue to develop in other Alpha Squadron planes that had received the same replacement parts. The immediate crisis had been resolved without loss of life or aircraft, but the underlying technical problems remained unresolved. Sarah's analysis provided the foundation for understanding what had gone wrong and what corrective action would be needed to prevent similar emergencies in the future. The component compatibility issues she had identified required systematic replacement of incorrectly specified parts throughout the affected aircraft fleet. General Thompson convened an emergency meeting to review the technical findings and develop comprehensive corrective action plans, with Sarah providing detailed briefings on component specifications and compatibility requirements. Her expertise, previously dismissed as irrelevant by intermediate supervisors, was now recognized as essential for resolving the crisis and preventing future occurrences of similar problems. The emergency had validated Sarah's technical analysis, while demonstrating the potentially catastrophic consequences of dismissing expertise based on organizational hierarchy rather than actual knowledge and competence. The lessons learned would influence future procedures for technical review and decision-making, ensuring that qualified personnel could contribute to safety discussions, regardless of their position in the organizational structure. The emergency command center had transformed into Sarah Chun's impromptu engineering laboratory as she spread technical manuals and component specifications across every available surface. General Thompson stood behind her, watching as she calculated failure probabilities and predicted engine degradation patterns for the remaining Alpha Squadron aircraft still airborne. The 2 successful emergency landings had bought them time, but 3 more F-15s were executing high-stress maneuvers over the Nevada desert, unaware that their engines contained the same incompatible components that had nearly caused catastrophic failures an hour earlier. Sarah's fingers moved rapidly across her calculator as she cross-referenced thermal stress data with operational flight parameters. The engines in the airborne aircraft would begin showing symptoms within the next 45 minutes if they continued operating at maximum performance levels. The mathematical models were unforgiving in their precision, indicating that component degradation would accelerate exponentially once critical temperature thresholds were exceeded during sustained high-power operations. Captain Lisa Rodriguez in Alpha 3 was currently leading a formation attack simulation against ground targets, pushing her engine to 97% power while executing tight turns that subjected every component to maximum gravitational forces. Lieutenant Colonel David Park in Alpha 9 was practicing air-to-air combat maneuvers that required rapid throttle adjustments and sustained high-speed flight. Major Jennifer Walsh in Alpha 15 was conducting electronic warfare exercises that demanded precise engine control for maintaining specific altitude and speed parameters. The radio communications from the airborne pilots reflected their complete confidence in their aircraft, voices calm and professional as they executed complex maneuvers with the precision that had made Alpha Squadron the base's premier training unit. None of them knew that their engines were operating on borrowed time, with components that were progressively failing under the very conditions that military training demanded. Sarah looked up from her calculations and addressed General Thompson with the kind of direct clarity that emergencies demanded. The airborne aircraft needed to reduce power immediately and return to base using minimum throttle settings that would prevent further component degradation. Any attempt to continue high-performance operations would result in engine failures similar to those experienced by Mitchell and Torres, but potentially more severe due to the accumulated stress already imposed on the mismatched components. The general's expression reflected the weight of decisions that could affect both mission readiness and pilot safety. Ordering the aircraft to abort their training exercises would compromise months of preparation for crucial evaluation exercises. However, allowing them to continue operations with compromised engines would risk additional emergencies that might not end as successfully as the morning's crisis. Communications specialist Amanda Foster established secure radio contact with the airborne aircraft while Sarah prepared technical briefings that would explain the engine problems without creating panic among pilots who were currently operating at high altitude and high speed. The explanations needed to be clear enough to ensure compliance with emergency procedures, but sufficiently detailed to help pilots understand the specific limitations they would need to observe during their return flights. Rodriguez was the first to receive notification of the engine concerns, her response reflecting the professionalism that had earned her selection for Alpha Squadron leadership responsibilities. She acknowledged the instructions to reduce power settings and begin immediate return procedures while requesting additional details about the nature of the technical problems. Her voice remained steady despite the obvious implications of being ordered to abort a critical training mission due to equipment concerns. Park's reaction was more skeptical, questioning whether the engine problems were actually serious enough to justify terminating exercises that had been planned for months and were essential for maintaining squadron readiness. His experience with F-15 systems made him confident in his ability to detect engine problems before they became dangerous, and his aircraft was currently showing normal operating parameters across all monitored systems. Walsh expressed similar concerns about the urgency of the situation, noting that her engine readings appeared completely normal, and that aborting the mission would have significant implications for the squadron's training schedule. Her questions focused on the specific nature of the technical problems and whether they were based on actual system anomalies or theoretical predictions that might not apply to real-world flight conditions. Sarah realized that the pilots needed more detailed technical information to understand why their apparently normal engines were actually operating in progressively dangerous conditions. She requested direct communication, access to explain the component compatibility issues and the mechanisms by which the problems would manifest during continued high-power operations. Her expertise in engine systems and component specifications made her uniquely qualified to provide the technical briefings that pilots needed. General Thompson authorized Sarah to conduct direct technical consultations with the airborne pilots, recognizing that her understanding of the engine problems was superior to that of any other available personnel. The decision represented a dramatic departure from normal military communication protocols, placing a civilian supply clerk in direct consultation with pilots during flight operations. But the circumstances demanded expertise rather than adherence to organizational hierarchy. Sarah's technical briefing was delivered with the precision and clarity that had characterized her written analysis weeks earlier. She explained how the mismatched fuel injection assemblies were creating combustion irregularities that would worsen under sustained high-power operations. The electrical component variations were causing sensor drift that would make it difficult for pilots to detect developing problems until they became critical. The hydraulic regulator pressure variations would affect control responsiveness during the high-stress maneuvering required for emergency procedures. Rodriguez was the first to acknowledge the technical explanation and begin implementing the recommended power reduction procedures. Her engineering background helped her understand the progressive nature of the component problems and the risks associated with continued high-performance operations. She began a controlled descent while reducing engine power to levels that would minimize further thermal stress on the mismatched components. Park initially expressed skepticism about the theoretical nature of the predicted problems, arguing that his engine was currently operating normally and showed no signs of the deterioration that Sarah's analysis suggested. However, as he began reducing power in compliance with orders, he noticed subtle variations in engine response that had been masked by the high-power settings he had been using throughout the training exercise. Walsh discovered similar anomalies. As she reduced throttle settings, finding that her engine exhibited minor fluctuations in fuel flow and temperature, regulation that became apparent only when operating at lower power levels. The problems were subtle but consistent with the patterns that Sarah had predicted, confirming that component degradation was already occurring even though it had not yet reached levels that would trigger cockpit warning systems. The return flights proceeded under Sarah's remote technical supervision, with her monitoring engine data transmitted from each aircraft and providing real-time guidance for power management and flight procedures. Her recommendations focused on maintaining engine operating conditions that would prevent further component degradation while ensuring that pilots retain sufficient power for safe flight operations. Rodriguez completed her approach and landing without incident, her early compliance with power reduction procedures having prevented significant additional damage to her engine components. Post-landing inspection revealed evidence of early-stage thermal stress in the fuel injection assemblies, confirming Sarah's predictions about the progressive nature of the compatibility problems. Park's return was more eventful, with his engine beginning to show minor irregularities during the final approach phase as accumulated thermal stress reached levels that affected normal operation. Sarah's real-time guidance helped him manage the power fluctuations through careful throttle control that minimized additional stress, while maintaining sufficient thrust for controlled landing. Walsh experienced the most significant problems during her return flight, with engine anomalies becoming apparent as soon as she reduced power settings according to Sarah's recommendations. The sudden change in operating conditions revealed component problems that had been developing throughout the training exercise, creating power fluctuations that required constant pilot attention and expert technical guidance for safe resolution. Sarah's remote troubleshooting during Walsh's approach demonstrated engineering expertise that impressed even experienced military personnel who were observing the emergency coordination efforts. Her ability to interpret engine data in real time and provide specific recommendations for managing component problems under dynamic flight conditions reflected technical knowledge that transcended traditional organizational boundaries. The successful recovery of all 3 aircraft validated Sarah's technical analysis while demonstrating the effectiveness of expert consultation during crisis situations. Her predictions about component behavior had been accurate, her recommendations for preventing further damage had been successful, and her real-time technical support had enabled pilots to manage engine problems that could have resulted in additional emergency situations. General Thompson convened an immediate post-crisis review session that included Sarah as the primary technical consultant for understanding and preventing future occurrences of similar problems. Her status had transformed from dismissed supply clerk to essential technical expert, whose knowledge was recognized as crucial for maintaining flight safety and operational readiness. The review process revealed systematic deficiencies in the procedures used for component specification and compatibility verification, deficiencies that had allowed technically qualified personnel to install parts that met individual specifications, but were incompatible as integrated systems. Sarah's expertise in understanding these complex interactions had been the key to identifying problems that conventional maintenance procedures had missed. Rodriguez found himself facing professional consequences for his role in dismissing Sarah's earlier warnings and proceeding with component installations that had created dangerous flight conditions. His experience and authority had been insufficient to compensate for his lack of specific technical knowledge about component compatibility issues. Sarah's comprehensive corrective action plan addressed both immediate safety concerns and long-term prevention measures, including revised procedures for component specification verification and enhanced technical consultation requirements for critical maintenance decisions. Her recommendations would influence base operations for years to come, ensuring that technical expertise would be recognized and utilized regardless of organizational position. The Alpha Squadron aircraft would require complete engine rebuilds using properly specified components, a process that would take weeks to complete but would restore the aircraft to safe operational status. Sarah's involvement in the rebuild process would ensure that component compatibility issues were properly addressed and that similar problems would not recur in the future. The crisis had demonstrated that expertise and authority were not always aligned within organizational structures, and that technical knowledge could be more important than rank or position when dealing with complex engineering problems. Sarah's vindication was complete, her competence was recognized, and her contributions would be essential for preventing future crises that could threaten both mission readiness and pilot safety. 3 weeks after the Alpha Squadron crisis, Sarah Chen stood in the newly established Technical Review Office, a facility that had been created specifically to ensure that engineering expertise would never again be dismissed due to organizational hierarchy. The office occupied a converted briefing room adjacent to the main maintenance hangar, equipped with computer terminals linked directly to aircraft maintenance databases and component specification libraries. Sarah's new title, Senior Technical Analyst, reflected both her vindication and the base's recognition that technical knowledge was too important to be subordinated to traditional authority structures. The morning briefing included representatives from every major operational unit on base, creating a level of interdisciplinary cooperation that had been impossible under the previous system. Colonel Patricia Hayes presided over the session, her leadership style reflecting lessons learned from the near-catastrophic failures that had resulted from dismissing qualified technical input. The briefing agenda included reviews of proposed maintenance procedures, component compatibility assessments, and long-term planning for system upgrades that would prevent similar crises from occurring in the future. Sarah's presentation focused on the systematic analysis of component compatibility issues that had been identified throughout the base's aircraft fleet. The Alpha Squadron problems had been only the most dramatic example of a broader pattern of technical deficiencies that stemmed from inadequate integration of engineering expertise into Maintenance decision-making processes. Her comprehensive review had identified 17 different aircraft systems where component compatibility issues posed potential risks to flight safety and operational readiness. The technical problems extended beyond the F-15 fleet to include compatibility issues in transport aircraft, training planes, and support helicopters that had received component upgrades without adequate engineering review. Sarah's analysis revealed that the systematic dismissal of technical expertise had created vulnerability across multiple aircraft types, with problems that would have manifested gradually but inevitably as components reached their operational limits under stress conditions. Major Kevin Barnes, who had been promoted to head the new Integrated Maintenance Division, acknowledged that the previous system had created dangerous gaps between technical knowledge and operational authority. His experience during the Alpha Squadron crisis had convinced him that successful military operations required seamless integration of engineering expertise with maintenance procedures and command decision-making. The new organizational structure was designed to ensure that technical competence would be recognized and utilized regardless of traditional hierarchical boundaries. Chief Petty Officer Michael Brennan attended the briefing as part of his continued service despite the professional consequences he had faced for his role in the component compatibility crisis. His demotion to a supervisory position reflected the military's recognition that experience and authority were insufficient substitutes for technical knowledge when dealing with complex engineering problems. Brennan's presence in the briefing demonstrated the organization's commitment to learning from past mistakes rather than simply assigning blame. The session included detailed presentations from Sarah's newly established team of technical analysts, civilian engineers who had been recruited specifically to provide independent assessment of component compatibility and system integration issues. The team included specialists in fuel systems, electrical components, hydraulic systems, and structural engineering, creating a comprehensive technical capability that complemented traditional maintenance expertise with advanced engineering analysis. Dr. Elizabeth Morrison, the team's fuel system specialist, presented findings from her analysis of injection assembly compatibility issues that extended beyond the Alpha Squadron aircraft. Her research had identified systematic problems with component specification procedures that had allowed incompatible parts to be installed in aircraft throughout the fleet. The problems were subtle but consistent, reflecting inadequate attention to the complex interactions between individual components and integrated systems. Senior engineer David Kim addressed electrical system compatibility issues that had been discovered during the comprehensive fleet review that followed the Alpha Squadron crisis. His analysis revealed that sensor accuracy problems were affecting multiple aircraft types with component variations that individually fell within acceptable tolerances but collectively created system performance degradation that could affect flight safety under extreme conditions. Systems analyst Jennifer Walsh, who had been recruited from the private sector specifically to address hydraulic compatibility issues, presented findings that demonstrated the complexity of modern aircraft systems and the sophisticated engineering knowledge required to ensure proper component integration. Her background in aerospace engineering provided insights that complemented military maintenance experience with advanced technical analysis capabilities. The briefing also included presentations from pilot representatives who described their experiences with the enhanced technical support procedures that had been implemented following the Alpha Squadron crisis. Captain James Mitchell, who had survived the first emergency landing, described how the new system provided pilots with detailed technical information that helped them understand their aircraft's condition and make informed decisions about flight operations and emergency procedures. Captain Rebecca Torres, who had experienced the second emergency landing, explained how the enhanced technical support had improved pilot confidence in aircraft systems and maintenance procedures. The availability of expert technical consultation during flight operations had proven invaluable during the crisis, providing real-time analysis and guidance that enabled successful resolution of potentially catastrophic situations. Lieutenant Colonel David Park acknowledged that the new technical review procedures had initially been met with skepticism from pilots who were accustomed to traditional maintenance and operational procedures. However, the comprehensive technical support provided during the Alpha Squadron crisis had demonstrated the value of expert engineering analysis for maintaining flight safety and operational effectiveness under challenging conditions. The briefing concluded with Sarah's presentation of long-term recommendations for preventing similar crises through systematic integration of technical expertise into all aspects of aircraft maintenance and operations. Her proposals included enhanced training programs for maintenance personnel, improved procedures for component specification and compatibility verification, and formal mechanisms for ensuring that technical knowledge would be recognized and utilized regardless of organizational position. General William Thompson, who had observed the entire briefing process, addressed the assembled personnel with remarks that reflected the profound changes in organizational culture that had resulted from the Alpha Squadron crisis. His comments emphasized that technical expertise was a critical component of military effectiveness and that the organization's success depended on recognizing and utilizing knowledge wherever it existed within the command structure. The general's announcement that Sarah would be leading a base-wide technical review initiative represented the culmination of her professional vindication and the organization's recognition of her unique capabilities. The initiative would involve systematic analysis of all aircraft systems, comprehensive review of maintenance procedures, and development of enhanced technical support capabilities that would prevent future crises, while improving overall operational effectiveness. Following the briefing, Sarah returned to her office to begin coordinating the expanded technical review initiative that would extend her analysis to every aircraft on the base. The project represented months of detailed engineering work that would require coordination with manufacturers, review of technical documentation, and analysis of component compatibility issues across dozens of different aircraft types and system configurations. The afternoon brought a visit from Amy Foster, who had been promoted to Deputy Technical Analyst, in recognition of her role in documenting and preserving the technical evidence that had been crucial for resolving the Alpha Squadron crisis. Amy's loyalty and professional competence had been essential for ensuring that Sarah's analysis was available when it was needed most, and her continued collaboration would be vital for the success of the expanded technical review initiative. Amy's new responsibilities included managing the technical documentation systems that would ensure proper recording and preservation of engineering analysis for future reference. Her experience with the Alpha Squadron crisis had taught her the importance of maintaining detailed records that could support technical decision-making, even when organizational pressures discouraged thorough analysis and documentation. The expanded technical review initiative began with comprehensive analysis of the F-15 fleet, including aircraft that had not been directly affected by the Alpha Squadron crisis, but had received similar component upgrades that posed potential compatibility risks. Sarah's systematic approach involved detailed examination of maintenance records, component specifications, and operational history for each aircraft, creating a comprehensive database of technical information that would support future maintenance decisions. The review process revealed additional compatibility issues that had not been apparent during the initial crisis, problems that would have manifested gradually as components accumulated operational stress over time. Sarah's analysis identified specific aircraft and systems that required immediate attention to prevent future emergencies, along with long-term recommendations for system upgrades and component replacement schedules. The afternoon also included meetings with aircraft manufacturers, technical representatives who provided additional insights into component compatibility requirements and system integration issues. These collaborations created unprecedented cooperation between military operations and civilian engineering expertise, establishing relationships that would support ongoing technical analysis and problem-solving capabilities. Sarah's expanded role included direct consultation with pilot training programs, providing technical education that would help aircrew understand their aircraft systems and recognize early warning signs of component problems. Her presentations to pilot training classes reflected the organization's commitment to ensuring that technical knowledge was shared across all operational specialties rather than being confined to specific technical positions. The evening brought recognition ceremonies that formally acknowledged Sarah's contributions to flight safety and operational effectiveness. Her Civilian Service Medal represented the military's recognition that expertise and dedication were more important than rank or position when it came to protecting personnel and maintaining operational readiness. Master Sergeant Rodriguez, who had been transferred to a training position following his role in the Alpha Squadron crisis, attended the ceremony as part of his continued professional development. His presence reflected the organization's commitment to learning from past mistakes and ensuring that future leaders would understand the importance of recognizing and utilizing technical expertise regardless of its source. The ceremony also included recognition for the pilots who had successfully managed the Alpha Squadron emergencies, acknowledging their professional competence and calm decision-making under extremely challenging conditions. Their survival had depended not only on their flying skills but also on their willingness to accept technical guidance from unexpected sources during critical situations. Sarah's acceptance speech emphasized that the Alpha Squadron crisis had demonstrated the importance of technical expertise in military operations and the need for organizational structures that recognized and utilized knowledge wherever it existed. Her remarks reflected both personal satisfaction at professional vindication and continued commitment to ensuring that similar crises would never again threaten pilot safety or operational effectiveness. The evening concluded with informal discussions among personnel from different specialties who had been involved in resolving the Alpha Squadron crisis. These conversations reflected the enhanced cooperation and mutual respect that had developed between technical and operational personnel, creating the foundation for continued collaboration and shared commitment to excellence in military aviation. Sarah's transformation from dismissed supply clerk to essential technical leader represented more than personal vindication. It demonstrated the military's capacity for organizational learning and adaptation when faced with evidence that existing procedures were inadequate. Her success had created opportunities for other technically qualified personnel to contribute their expertise to operational effectiveness, regardless of traditional hierarchical limitations. The future held continued challenges as the technical review initiative expanded to encompass all aircraft operations on the base. But Sarah approached these challenges with confidence earned through successful resolution of the Alpha Squadron crisis. Her expertise was now recognized and valued. Her recommendations were implemented and supported, and her contributions were essential for maintaining the safety and effectiveness of military aviation operations. The Alpha Squadron aircraft had been returned to service following complete engine rebuilds using properly specified components, supervised by Sarah's technical team to ensure that compatibility issues were properly addressed. The pilots who had survived the crisis had become advocates for enhanced technical support and systematic integration of engineering expertise into all aspects of flight operations. Sarah's office maintained detailed records of all technical analyses and recommendations, creating a comprehensive database that would support future maintenance decisions and prevent similar crises from occurring. Her work had established new standards for technical excellence that would influence military aviation operations for years to come, ensuring that expertise would be recognized and utilized. regardless of organizational position or traditional authority structures. 1 year later, Sarah Chen stood on the observation deck of the newly constructed Technical Excellence Center, watching as Alpha Squadron's F-15 Eagles performed flawless aerial maneuvers against the desert sky. The aircraft moved with precision and power, their engines operating at peak efficiency with components that had been meticulously selected and verified through the comprehensive technical review procedures she had developed. Each successful flight represented vindication of the principle that expertise should guide decisions regardless of organizational hierarchy. The Technical Excellence Center had become a model for military installations worldwide, demonstrating how systematic integration of engineering knowledge could enhance both safety and operational effectiveness. Sarah's position as Director of Technical Integration reflected the military's recognition that her unique combination of theoretical knowledge and practical experience was essential for maintaining the highest standards of aviation safety and performance. The morning brought delegations from 3 other air bases seeking to implement similar technical review programs, acknowledging that the procedures developed at Fairfield had prevented numerous potential crises while improving overall fleet readiness. Sarah's presentations to visiting personnel emphasized that technical excellence required both rigorous analysis and organizational cultures that valued expertise over traditional authority structures. Captain James Mitchell, now serving as Alpha Squadron's commanding officer, approached Sarah with the monthly operational report that documented the squadron's perfect safety record since the implementation of enhanced technical support procedures. His experience surviving the engine crisis had made him one of the strongest advocates for systematic technical review, and his leadership ensured that pilots understood the importance of technical expertise in maintaining flight safety. The report detailed how the integrated technical support system had identified and resolved dozens of potential component compatibility issues before they could develop into operational problems. Sarah's team had prevented multiple crises through proactive analysis and systematic review of maintenance procedures, validating the investment in technical expertise that had initially been considered unnecessary by traditional military leadership. Dr. Elizabeth Morrison joined Sarah on the observation deck, carrying analysis results from the latest fleet-wide technical assessment that had been completed the previous week. Her findings demonstrated that the comprehensive technical review procedures had eliminated component compatibility problems throughout the base's aircraft fleet, creating unprecedented levels of system reliability and operational readiness. The conversation turned to the invitation Sarah had received to address the National Defense Technical Conference, where she would present the Fairfield Air Base model to senior military leadership from across the country. Her presentation would demonstrate how technical expertise could be systematically integrated into military operations, creating safer and more effective organizations that valued knowledge over rank when dealing with complex engineering challenges. Amy Foster, now serving as Deputy Director of Technical Integration, arrived with documentation for the latest technical review cycle that would begin the following week. Her continued collaboration with Sarah had been essential for developing the comprehensive procedures that ensured proper technical analysis of all maintenance and operational decisions affecting aircraft safety and performance. The technical review procedures had evolved into a sophisticated system that combined computer-based analysis with expert human judgment, creating multiple layers of verification that prevented component compatibility issues from reaching operational aircraft. Sarah's team had developed software tools that automated much of the analysis while ensuring that human expertise remained central to critical decision-making processes. The afternoon brought news that the Alpha Squadron crisis had been selected as a case study for the Air Force Academy's leadership curriculum, demonstrating how organizational learning could prevent future crises while improving overall effectiveness. Sarah's role in the crisis would be taught to future officers as an example of how technical expertise could emerge from unexpected sources and how effective leaders recognized and utilized knowledge regardless of its origin. Master Sergeant Rodriguez, who had completed his professional development program and returned to active maintenance duties, stopped by Sarah's office to discuss the latest training materials for maintenance personnel. His experience during the Alpha Squadron crisis had transformed his understanding of the relationship between technical knowledge and operational authority, making him an effective advocate for systematic technical review procedures. The training program Rodriguez was developing would ensure that future maintenance personnel understood both the technical aspects of component compatibility and the organizational importance of recognizing expertise wherever it existed within the command structure. His materials emphasized that successful military operations required seamless integration of technical knowledge with operational experience and command authority. Sarah's reflection on the past year revealed how the Alpha Squadron crisis had catalyzed fundamental changes in organizational culture that extended far beyond technical procedures. The military's recognition that expertise was more important than rank when dealing with complex technical problems had created opportunities for qualified personnel throughout the organization to contribute their knowledge to operational effectiveness. The evening brought the annual awards ceremony, where Sarah would receive the Defense Technical Excellence Award for her contributions to aviation safety and organizational effectiveness. The award recognized not only her technical competence, but also her persistence in advocating for proper technical procedures, despite organizational resistance and professional risks. General William Thompson's presentation speech acknowledged that Sarah's technical analysis had prevented potentially catastrophic failures, while demonstrating the importance of organizational structures that recognized and utilized expertise regardless of traditional hierarchical boundaries. Her success had established new standards for technical excellence that would influence military aviation operations for decades to come. The ceremony also recognized the pilots who had survived the Alpha Squadron crisis, acknowledging their professional competence and their subsequent advocacy for enhanced technical support procedures. Their survival had depended on accepting technical guidance from unexpected sources during critical situations, demonstrating the importance of organizational flexibility during emergencies. Sarah's acceptance remarks emphasized that the Alpha Squadron crisis had revealed both the dangers of dismissing technical expertise and the potential for organizational learning when faced with evidence that existing procedures were inadequate. Her experience had demonstrated that technical knowledge could emerge from any position within an organization and that effective leadership required recognizing and utilizing expertise wherever it existed. The evening concluded with informal discussions among personnel from different specialties who had been involved in developing the enhanced technical review procedures. These conversations reflected the sustained cooperation and mutual respect that had developed between technical and operational personnel, creating a foundation for continued excellence in military aviation operations. Sarah's transformation from dismissed supply clerk to recognized technical leader represented more than personal vindication. It demonstrated the military's capacity for organizational adaptation when faced with evidence that existing procedures were insufficient for complex technical challenges. Her success had created lasting changes that would benefit military aviation safety and effectiveness for years to come. The future held continued opportunities for technical excellence as the procedures developed at Fairfield Air Base were adopted by military installations worldwide. Sarah's expertise would continue to influence aviation safety standards and organizational procedures, ensuring that technical knowledge would be recognized and utilized regardless of traditional authority structures. The Alpha Squadron aircraft continued to operate with perfect safety records, their engines performing flawlessly with components that had been properly specified and verified. through comprehensive technical review procedures. Each successful mission represented validation of the principle that expertise should guide critical decisions affecting personnel safety and operational effectiveness. Sarah's office maintained comprehensive records of all technical analyses and organizational improvements, creating a permanent repository of knowledge that would support future technical excellence initiatives. Her work had established new standards for systematic integration of technical expertise into military operations, ensuring that the lessons learned from the Alpha Squadron crisis would prevent similar problems from occurring in the future. The observation deck provided a perfect view of the flight line where aircraft prepared for missions with complete confidence in their technical support systems. Sarah's daily presence there served as a reminder that technical expertise was essential for maintaining the safety and effectiveness of military aviation operations, and that knowledge should be recognized and valued regardless of its source. Within the organizational structure. Up next, you've got two more standout stories right on your screen. If this one hit the mark, you won't want to pass these up. Just click and check them out.